Hello students, and welcome to the lab tutorial for the Temperature Inversion Lab. In this lab you're going to be learning about how to graph and how to determine if there is a temperature inversion and then make some analyses regarding what pollutants will do in a temperature inversion. So let's read this intro. In some cities, the weather report often warns of high air pollution levels. People are asked not to drive unless it is absolutely necessary, and open fires and barbecues are forbidden. A frequent reason for high levels of air pollution near the ground is a temperature inversion in the atmosphere. Although temperature and pressure in the overall troposphere decrease with height, the temperature inversion is an exception to this rule. So this is an important point. Normally in the troposphere, the overall temperature and pressure are going to decrease. So if you start here at 0, like sea level, and you go up, the temperature will go down. So the height will go up, temperature will go down. So the problem here is, how can you detect a temperature inversion, and how does it trap pollution? The only materials you'll need is a ruler and a calculator. Nothing big, and a ruler you just need a straight edge, really. And a calculator you don't have to have. You can do the math by hand. It's just simple adding and subtracting, but it's just faster with a calculator. So your objectives are to graph the temperature data for the atmosphere, describe how temperature inversion affects ground level pollution. So what I would like you guys to do is read through all of the procedure. It's on this side too. They're printed front and back. Read through the whole procedure first, and then go back and start with step 1 and start to complete it. So you can go ahead and pause this video right now and read the entire procedure, just so you get a good idea of what to expect and what you're going to do. You also may want to read the analyze questions, just so you know what you're looking for, and the conclude and apply questions right here. I always like to read through the entire lab before, just so I know what to expect. And then you're going to go back to number 1. And as you read through these procedures the second time, you're going to complete them as you go. So procedure number 1, use box 1 to graph data sets A and B. So I'm going to stop there and just take a look. Okay, where is that? Okay, here's data set A, here's data set B, and here is box 1. So this is where you're going to graph it. I'm going to show you how to graph it in this location. If you want to use a program like Microsoft Excel or something, that's totally fine. You can use that if you're familiar with that. Let's go back to the second part. So then it says the horizontal means this direction, axis will be height, and the vertical axis, this direction, will be temperature. Label these axes. So I'm going to go to my box 1 and I'm going to do it right now. So right here, this is the horizontal. This is going to be height. And it's kind of messy because I have to write kind of far away so I can film it properly. So it's kind of hard to write at this angle, so that's why it kind of looks like kindergarten writing. And in addition to the height, you also want to put your units. So if you look up here, the units right here are meters. So you always want to put the units on a graph. And then you're going to do, and then it says do temperature on the vertical axis. So that will go right here. So I'm going to turn the paper sideways and write. Well, I think it's because I can't see my writing, except I'm looking through the video is why it looks so funny. Temperature, and we're going to put our units, it's degrees Celsius. All right, good. So next step. Look at the data sets and choose suitable ranges and intervals for the axes. Mark the axes accordingly. All right, so let's look at our data sets. What you're going to want to do is look at your smallest number. So we're going to do height first here. You're going to do your smallest number and then your largest number. So we need, our range is from 0 to 700. So that needs to be evenly spaced along this bottom axis. So I'm going to do Since it's every 100, there's no intermediate values. You don't really have to worry about how far. You just want to stretch it out pretty far so that it takes up most of this graph space. You don't want a graph that only takes up this one. So you don't want to go like 100, 200, 300, 400, 500, 600, 700, because then all this is wasted space. And the bigger your graph can be, the more exact and precise your points can be on your graph. So I'm going to take 5 spaces for each 100. So that'll be 100, or 1, 2, 3, 4, 5. Oops. And mark that as 100. And then 1, 2, 3, 4, 5. Mark that as 200. 1, 2, 3, 4, 5. 300. 1, 2, 3, 4, 5. All the way up to 700. Now, always your increments down here are equal in number and evenly spaced. So this 5 lines, these 5 boxes, always equals 100. So that's 100, 100, 100, 100 every time. It has to be equal in distance and equal in number. You can't do like 100 here, so 5 boxes equals 100, and this one is 300. You couldn't do that. It has to be the same amount. And we're going to do the same thing with temperature, although it's a little difficult, more difficult, because you have decimals. They're not evenly spaced automatically, so you're going to have to figure this one out. So the highest number is 20, so that's what's going to be up here somewhere. The lowest number is 15.5. So I'm going to start with right here, this box right here. It's not 0, it's 15. You can start like that, and all you're doing is assuming under here would be 0, but there's no values under there, so there's no point in putting that on your graph. You can start with a number like 15. You don't have to start with 0. So 15, and then we have to go all the way up to 20, and what I see is there's a lot of halves. So in order to make it easy, I would do every 4 numbers in this case to equal a number. So that'd be 15. This would be 1, 2, 3, 4, and then this would be 16. That way this number right here is 15.5. It's an easy line since there's lots of 5s. That just makes it easy on you. So this is 16, 17, 18, 19, 20. And I want you guys to notice these numbers are equal. This is 1, this is 1, this is 1, 1, 1, equal in number and equal in distance. I did not use these numbers on the axis. We don't use random numbers. We don't just start putting 20, 19.5, 18.7. That is an incorrect way to graph. You want to put these numbers that are equal in distance and equal in number. Okay, let's go back to the other side. Okay, so now number 3, you're going to plot data set A on your graph and connect the points with a solid line. A solid line meaning like this. You're going to do plot data set B on the same graph and connect the points with a dashed line, which would be like this, to tell the difference. You could also use 2 different colors if you prefer, although the directions say this, so this is easy. So then we're going to go to our graph and our data sets. So at height 0, temperature is 20. So at height 0 here, temperature, we go straight up to 20 and put a dot. Then at height 100, temperature is 19.5. So height 100, we go straight up. So this was 19, this is 20, so 19.5 is right in the middle, right there. Now we continue doing this with all of our data. So it's 18, 18 and a half. So this is 0.5, 6, 7, 8, 9, 10. So it's 18.7, so that would be somewhere 5, 6, 7, somewhere right, like close to right there. All right, you're going to keep doing that with your data numbers. And what you should see on this one is that they should generally go, I'm not going to do them exactly, but they should go pretty evenly like that, so that you can take your ruler and you can connect these lines. Now, we don't need to connect these ones like because you can see a general trend, a pretty clear line straight through like that. So it should look something like this. Just make sure your data points are accurate. I'm not going to do the whole thing for you guys. And then we're going to do the same thing with data set B, but remember we're using a dashed line. So, oops, let's move this over just a little. So for 0 meters, it's 20, so that's the same. So a second dot is going to go right here. For 100 meters up, and so we're increasing height as we go, so we're going farther away from the surface. So 100 is 19.3. We'll mark it. 18.8, mark it. 18, mark it. Oops, right here, we'd mark it. Then you'd go 19, so it goes up after this. So you'll see it go, instead of keep going down in this pattern, it's going to start going up. You'll see a graph, something like that. And then you do dashed lines to connect that. In addition to that, you're going to want to, over here, make a key and say the straight line is data set A, make sure it's clear. The dashed line is data set B. And then your next set of directions is to give the graph a title. So you're going to want to give it a title up here. Always title your graph, and it needs to be specific. Or I'm sorry, title would go right here. It needs to say something like the temperature change as height increases. So you see heights increasing, right? I'm sorry, over here, heights increasing. How is the temperature changing? So in this first example, the temperature is decreasing as height is increasing. And then this one, the temperature is going to decrease and then increase and kind of level off. So your next step, guys, is on number 5. You're going to read this about density, and then you're going to convert all those numbers, all the Celsius, to Kelvin by adding 273.15. So you're going to add that and put the data set here. So this plus 273.15 goes here. That goes here. Now the next one talks about figuring out density, but I gave you the density for you right here, so you do not need to complete number 6. You read it, please. But I completed that data for you. And then continue on the back, read all this about density. And then you're going to, in box 2, make a graph of density versus height, similar to the graph you made here. So all the same steps, put your axes in, make your key, write your table, do your 2 lines, and you should see a similar graph to the first one. Because density is proportional to temperature, and that's what you're going to find out. Is how if temperature is always going down, density is always going to go down. If the temperature goes down and then up, the density should go down and then up. So you'll graph that on box 2. Make sure you title, make a key, label your axes with the units, and increments are correct. And then you're going to answer the analyze questions and the conclude and apply questions. So just make sure you're clear on your answers about these. It needs to match what your graph says, and that's what I'll be looking for. And I think that is it. So good luck, everyone, with your lab. Let me know if you have any questions or concerns, and have fun. Thanks, everybody.